Hi, this is just a brief video going through the learning targets and the vocabulary from Chapter 2. In Chapter 2, you are going to, we're going to look at some standardized test scores, z-scores in Chapter 2. We will be introduced to the concept again of density curves, which were really just sort of like our normal curves or overall shapes of distributions. And then we'll talk a little bit about the effect of adding, subtracting, and multiplying by different constants. So the learning targets at the beginning of Chapter 2 were, can I describe the location of an observation with a percentile? Again, a percentile is what percent is your data point better than. There's a few different definitions. It's either what percentage of people are at that point that you are and below you, or what percentage of people are just below you. So just understanding percentile. Interpret a cumulative relative frequency graph. That's the idea that when you look at your graph, by the time you get to the upper right of the graph, you will have covered 100% of your data. So you want to look through some of those examples in your book. Then there's how do you calculate a z-score? Again, a z-score is how many standard deviations are you above or below the mean? So you should be able to explain that in terms of context. And again, notice they call it a standardized value back in Chapter 2, and that's because all the tests that we've done in Chapters 9 and 10, even a little bit of the chi-squared, we're finding standardized values. And again, those values are telling us how many standard deviations are we away from our mean. And then the last kind of piece is the effect of adding or subtracting a constant. How does that affect your shape? Doesn't affect your shape at all. How does it affect your center? Well, it affects your center by adding or subtracting your center by that given constant. And how does it affect your spread? Adding and subtracting does not affect your spread, your standard deviation at all. The numbers will still deviate from the mean the same way. The effect of multiplying or dividing doesn't change your shape. It still will be the same shape. The center will be either multiplied or divided by that constant, and the spread will be either multiplied or divided by a constant. So multiplying and dividing, it affects the center and the spread. Adding and subtracting only affects the center of your data. So that's the first part of Chapter 2. So I just briefly want to show you again that relative cumulative frequency plot. It says, notice the graph up here in the upper right. It gets you all the way up to 1, and that's representing 100%. It starts down at 0, and then each time along the way it's just accumulating your totals. It says James earned a score of 33. Calculate and interpret his percentile. So you first look for 33 on your graph. You drag up, so 33 is maybe this point, and then you look horizontally, so somewhere between 60 and 70% of the people have scored at or below James's score. And then you can do the same thing for looking at 12. Again, go to your graph. Where's 12? Maybe this dot or that dot. So if it's this one, look somewhere just below the 20th percentile. And then you can use the graph the opposite direction, use that relative frequency graph for what percentile is a score again, at what percent is a score of 38, so same thing, just go to where's 38, maybe this dot, and that looks to be maybe about 82%, or the 82nd percentile. When it says, use the cumulative relative frequency to estimate and interpret quartiles, again, quartiles are at 25 and 75, so you would go to 25, so between here, and that first quartile looks somewhere around 15 for a quiz score, and then you go up to 75, go across 75, somewhere in here, somewhere between maybe 35. So that's how you use a relative cumulative or cumulative relative frequency graph. The second half of Chapter 2 is about density curves, and when we first learn about our normal curve. Again, a density curve is just the general sort of shape or a smooth line curve of your distribution. So when you draw a little curve over your histogram, you're sort of making a density curve. Remember, the area under every curve adds up to 1 or 100%. And then it just learned a whole bunch of different values or different facts about a normal distribution. Again, normal distribution has that 68, 95, 99.7 rule, 1 standard deviation, 2 standard deviations, and 3. We can find the areas and percentiles by calculating z-scores, looking them up in our table, or using our calculator features. And I kind of mentioned that in the previous video of where those calculator features are. And again, that table you should be able to kind of look up and use. And then the last one, justify whether or not a distribution can be described as normal. One way to prove if a distribution is normal is to check, is 68 or approximately 68% of the data within 1 standard deviation away from the mean? And then check, is approximately 95% of the data approximately, or 95% of the data approximately 2 standard deviations away from the mean? And check again, is approximately 99.7% of the data within 3 standard deviations of the mean. That's one way to justify. The other way is to use a normal probability plot. And again, there's a calculator shortcut in your textbook, but in a normal probability plot, it's plotting typically your explanatory variable or your variable that you're measuring by their z-scores. And you're looking for that plot to be linear, that as your values increase, their z-scores increase at a sort of a constant rate. And that proves that there is a normal distribution to your data. So those are some of the things from Chapter 2. The last question that just comes up a little bit is when you're looking at a density curve, it does not have to be curved. A density curve could be what we call uniformed, or just have a straight line. Again, the area under this still has to add up to 1. Notice the shape is a rectangle, so 2 times a half, that area would be 1. So recognize that it has height, it has length, and then it says the density curve below taking the value of 0.5 for the entire interval and 0 everywhere else. What percentage of the observations lie between 0.4 and 1.8? So really you just got to find your width. What's the difference of 0.08 minus 0.4? So that is 0.68. And then because the height is only a half, 0.68 times a half tells you your width times your length, or base times your height, and you get B, that it's about 34% of your data falls within there. So there are some uniform density curves that we talked about in Chapter 2 as well. So now take a minute, go through that Chapter 2 relearn worksheet and see if there's any questions or concerns that you have. Again, highly recommend looking at your chapter summary for Chapter 2, looking at the learning targets and other examples if there's something that you don't understand. Thank you.